Another place where we encounter systems of linear equations is when we're dealing with mixtures. And there are a lot of different kinds of mixtures we might be dealing with. But they're especially popular. And so let's talk for a minute about how we can tell that we're dealing with a mixture. In this problem, it's really easy to tell that we're dealing with a mixture because the word mixing is right in the problem. But in general, when we're combining two different kinds of things, and we're interested in information about both each individual thing and the mixture, well, that's when we have a problem that involves mixing. All right, so let's take a minute to understand this problem. A chef is mixing two salad dressings. The first dressing is 7% vinegar and the second is 15% vinegar. How much of each dressing should he use to create 50 milliliters of a dressing that's 12% vinegar? Round our answer to the nearest milliliter. All right, so there's a bunch of information here, but it all has a lot of stuff in common. Right, I have information about the first dressing, the second dressing, and the mixture. And I have kind of all the same sort of information. And when that happens, I want to make a table. I'll be honest with you, I tend to reach for tables at the drop of a hat. Right, because I notice that this information has something in common. The big piece of information I notice that we have about everything is the percent vinegar. Right, the first dressing is 7% vinegar, the second dressing is 15% vinegar, and the mixture is 12% vinegar. Right, I also notice that we have information about how much of the mixture, and our unknowns, right, are about how much of each dressing. Right, how much of each dressing should he use? Right, okay. I know what I want to find. Right, what are the rules here? Well, the rules are, if I take the vinegar from my first thing and the vinegar from my second thing, right, I'm going to get enough vinegar so that my mixture is 12% vinegar. Right, so my rules are about the total amount of the mixture and about the total amount of vinegar. Right, spotting this rule, I think, is the hardest part of one of these mixture problems involving concentration. Right, so whenever you see something about concentration, look for one of these rules about the total amount of stuff you end up with. Okay, I think we understand this problem. Right, I think we're ready to model. Okay, so our first dressing and our second dressing are unknowns. They're both amounts of dressing. I'm going to just call them X and Y. You are free to call them F and S, for example, if you want to. Right. And we can write down an equation from that about the total amount. X plus Y is 50. How much vinegar? Well, how much vinegar is in the mixture, right? It'll be 12% of my 50 milliliters. That's 50 times 0.12. I'll have 6 milliliters of vinegar in my mixture. How much do I get from my first dressing? 7% of X, 0.07x. How much do I get from my second dressing? 0.15y. Right? And then the amount in the mixture is the amount from the first dressing plus the amount from the second dressing. This is why we talked about these linear models from mixtures earlier, by the way. Is that enough? Are we going to be able to solve this now? I think so. I think we've successfully modeled our problem. So our system is going to be this system. Pause the video and try solving this system now. Make sure that you notice that the number I wrote here is a 5, not a 3. Okay, what do we find? Now, looking at this second equation, I noticed these decimals. If you'd like, you could multiply both sides of this second equation by 100 to make those go away. I'd rather just deal with the decimals right now, though that's pretty much a matter of personal taste. If you multiply both sides of this by 100, you will eventually get the same answer. Looking at this system, I think I want to use elimination. And I think what I want to do is multiply both sides of the first equation by negative 0.07. When I do that, I get negative 0.07x minus 0.07y equals negative 3.5. Add together the left-hand sides. I get 0x, that's eliminated. 0.08y equals 2.5. All right, divide both sides by 0.08. I get y equals 31.25. Right, I'm going to use the first equation to find x, because it's way easier to work with. Subtract 31.25 from both sides, and I get x equals 18.75. All right, now we're ready to answer the question. Let's take a look back at the instructions. Round our answers to the nearest milliliter. Okay, so I got x equals 18.75. To the nearest milliliter, I want 19 milliliters of the first dressing. I got y equals 31.25. To the nearest milliliter, I want 31 milliliters of the second dressing. Do those make sense? Well, first of all, if I mix them together, I'm going to get 50 milliliters, so that's good. I'm going to actually quick check how much vinegar I get. I'm going to do 0.07 times 19 plus 0.15 times 31. Right, and then divide that by the 50 milliliters of the mixture, and that's super close to 12%. Do I expect exactly 12%? No, because I rounded my answer. So my mixture actually works out the way that I hoped that it would. These numbers seem reasonable. Yes, I think that this answer does make sense.